this will have a mass m, bob of mass m. This will be light string. Okay, now if I release it, it will come to these various positions. Okay, let's discuss some expression for time period of pendulum. That one. So the weight mg will act, string will be taut, tension will be set up here. Let this be theta. Then torque set up about point of suspension. That should be equal to, this distance is what, how much, L sine theta. So torque about point of suspension should be equal to mg L sine theta. This torque should be equal to I naught alpha. How is the angular displacement given? In this direction, whereas the alpha is in this direction. That's why this negative sign. So mg L sine theta. Moment of inertia ml square into alpha. And this is the light string. The string will be light. So therefore this alpha will become GL G minus G by L sine theta. No, this is not SHM. When theta very small means around 18 degrees. Roughly, there is no particular boundary. Theta should be less than for SHM. Not perfect, most of the books. Anyway, theta between 0 and 18 degrees, we can treat that to be an SHM. Few radians it is. Pi radian 180 degrees, pi radian 180 degrees. So approximately you can go for 3.14. No, 1 radian will come around 60. So very small, this one. So in terms of theta, it will be around 18 degrees is what we are taking. Some books they meant even for 15. So I'm just taking it to be around 18. Then the sine theta will become, comparing with angular SHM, omega equal to G by L. So time period is given by 2 pi L by G. So this is the expression for time period of pendulum. What is the time period? Time taken to complete one oscillation. Again, here also we can define the similar thing. Theta equal to theta naught sine omega t. What is this sine omega t? Omega is given by this one. Omega, will write it here. What is theta naught? Angular displacement given to the system. So theta equal to 0 degree, we define this line. White color. Theta naught, maximum angular displacement. What do you mean by this? At you are giving some angular spin for it. Some omega naught you are giving it, and because of that, the maximum angular displacement it can have is equal to theta naught. There's an angular amplitude. What is theta naught? You should call maximum angular displacement or angular amplitude. If you define t equal to 0, this particular point, it will be like this. If this is the mean position, something the angular velocity you are giving in this direction. If you release from right extreme, okay, if the bob released, when to write this equation, when bob released from right extreme. When bob is Okay, you start counting time when the bob is at mean position, then the equation should be off like this. Okay, some math-based questions can be asked in exam. All possibilities there. That's why I'm just trying to stress. This will have a phase angle of 0, pi by 2, pi, 3 pi by 2, and 2 pi. Similar to like yesterday's what we discussed for spring block system. The same condition is applicable for this. After this, we have a seconds pendulum. What do you mean by seconds pendulum? Seconds pendulum whose time period will be 2 seconds. So what is a seconds pendulum? Whose time period will be 2 seconds. That is called like a seconds pendulum. Nothing is there. The time period of oscillation, that pendulum is so designed, the length is so designed that it will take 2 seconds to complete one oscillation. That is called like a seconds pendulum. A seconds pendulum is used means indirectly we know the length. And the numericals, these are the ways in which you should have the information. Okay, no, even the SHM equations will be written of this kind. You have to be careful. If it is released from here, we'll write minus cos, minus all this one, negative angular displacement. Okay, after this, we'll take the conditions. If the pendulum is oscillating such that if you consider the effect of medium surrounding it, that the density of